Okay, so in this video, we're going to come to the Black-Scholes Greeks and come down to graphics. Now we had done this before previously, so I'm just going to copy this snippet of code. I want to visualize the Greeks, and this is a really streamlined way of doing that. There's a package authored by Professor MacDonald, who is author of Derivative Markets, his textbook. I've left a link there to that just here. And we can go into the R package derivatives, and there is a compiler in here. We just need to paste. In fact, I think I can just paste here and we can get the output. So basically, we have the library, we have these parameters that we've been using all the way through. The asset price is 100, K is the exercise 100, the volatility 20%, R is 5%. The maturity here is given as 1 year, no dividend yield. And if we run this, we get some outputs, but the one we're interested in is the visualization of the delta, gamma, vega, theta, and rho. So let's just run that. And again, those those Greeks look familiar and consistent with previous results. But what I would like to look at here is the visualization, so we can see the familiar call and put Black-Scholes parabolas for these parameter inputs. And we're mapping from 10 to 200 in steps of 5. So S is sequentially generated going from 10 to 200 steps of 5. So we're producing a range of estimates. We have roughly 20, probably 40 data points, and we're generating with the 40 data points these outputs here. So we've a call and a put, Black-Scholes parabola. We've the delta for the call, delta for the put, gamma for the call, gamma for the put, vega for the call, vega for the put, and then the call rho, put rho, call theta, put theta, and you can see mainly negative. If we change the dividend to being positive, the theta will become, there will be a region that's slightly positive. Let's just have a look at that and run. Let's come down. So we've just changed the values here for dividend to be 5%. Let's run this again and we'll get a slightly different output. We should be able to see that theta, there's a region here for theta where it is positive. Okay, okay, that as it is, let's leave that here, and then in the further explanation down in the Vinegar Hill website, we'll use Excel to explain how we generated the analytical results here, and also the visualization. So how do we build this up from first principles? Notice here that the call theta, it has now a positive region. Before it was negative. If we change the 0.5 back, just change that back to 0 as before and run, that positive region is gone. Okay, so let's take a look. And you see the positive region is gone. We're in a negative region. Okay, so I'll pause here and stop,